Question number 15. 75 joules of thermal energy is transferred to an ideal monoatomic gas. Ideal once again, which means what? You can always use PV equal to NR. No issue. At a constant pressure, when constant pressure is used, that means what? V1 by T1 is equal to V2 by T2. You can use this also. Of constant pressure, P is given to you. This is supplied energy. Oh, this you have to be careful. Okay, supplied energy, this is a total energy being supplied. And then the volume of the gas increases from this to this. There's an increase in volume. What is the increase in volume? Delta V should be equal to V2 minus V1, which should be 3 minus 2.7, which is 0.3 multiplied by 10 power minus 3 meter cube. What is the change in internal energy? See, the moment you give this total supply, energy supplied and internal energy, what is that you need to do? First law of thermodynamics, which should be Q is equal to U plus W, right? The energy that you supply increases the temperature and also does some work on it. This is what it is. So therefore, now you are going to find the internal energy. Internal energy U should be Q minus W. Now how do I get this W? W is nothing but P delta V, right? Okay, what do you mean by P delta V? That means it's either contracted or expanded. Something has happened. So therefore, now you can calculate this value. What is that value? So this should be 1 into 10 to the power of 5. P you have got multiplied by delta V. Delta V calculated over here, which should be 0.3 into 10 power minus 3, which should now be equal to 0.3 into 10 square, which should be equal to, how much is it? 30 joules over here. Okay, this is the amount of work done. So therefore, what's the value of Q? 75 minus, this should be 30. So how much is it? 45 joules. So the answer is 45 joules. Okay.